Very good evening to everybody over here, and welcome to another session that we're doing on HackWithInfy. So in this session, I'm going to cover another previously asked question, or rather a question that's available for HackWithInfy. And so we've looked at some of the questions and we've figured out what are some of the questions that can be asked. So I'll be covering this question called weird elevators today. It's a good approach, it's a maths approach. But before I get to that, just a reminder to everybody that if you are looking to prepare for HackWithInfy round 2, this is specifically for those people who cleared round 1 who want to prepare for HackWithInfy round 2, then we have a special course over here. It's called the HackWithInfy round 2 preparation pack, and you can check it over here in the bit.ly/Edyst/Edyst-HWI, bit.ly/Edyst-HWI. The link is also mentioned in the description below. When you go to the following link, you will come up with this page. And if you're already part of our partnered colleges and already have access to this course, you can completely ignore this part, and you can just forward about 5-10 minutes where we actually start the question. So you come here. We have really nominally priced it so that you can just take it just before the test, and you can try out this one free module. These are some of the topics that we cover over here. Just one thing I want to very clearly point out is that this HackWithInfy round 2 is a difficult pack. It's a difficult test, and so if you don't already know certain concepts of maths, arrays, bit manipulation, then this course is not for you. Please don't take this course if you're not already good at the basics of programming. If you've cleared HackWithInfy round 1, I assume you're already good at the basics of programming. So if you click on this round 1, this try free module, you come up to this page over here, right? So when you come up to this page, you'll see that there's a playground. This is free, completely free. So even if you are not joining up the course, you can actually take this course for free, this module for free, and you can try out some of the questions. And again, the questions are some of the previously asked questions itself. So you can come try out some of these questions as well. Special set bits is an interesting question that we covered in the round 1 last time, and a lot of people are still not able to solve it. So check out that question over there. Right, and apart from that, we have a bunch of mock tests as well. So we have a bunch of mock assignments, and so once you unlock it, this is what it will end up looking like. One second, let me just open up that page for all of you. Right, yeah, so this is what it will end up looking like for all of you. I'm just going back here. Right, so once you unlock everything, this is what it will look like. This is the mock assignment number 1. Like that, we have mock assignment 2, 3, 4, 5, 6 mock assignments for you to take to test out, and also a 6 Edyst scheduled assessment. So that will be available here. If you come to contests and you'll check out all the contests that are available, you'll find out that there is Edyst schedule. So for example, we already completed 2 mock tests, 2 contests. So there's HackWithInfy contest 3, contest 4, contest 5, and contest 6. Right, and the schedule for that is also available over here. So in the upcoming days, we are going to schedule a few more mock tests, so you can check that over here. 1 second. Yeah, so we already conducted 13th May and today 16th May is mock tests. There are 4 more mock tests to be conducted in addition to the 6 mock tests that you can schedule for yourself. So overall 12 mock tests are available for you if you want to go ahead and take this pack. So this is a pack again specially designed for people who want to go into HackWithInfy round 2. So 6 self-scheduled mock tests and 6 Edyst scheduled mock tests. Apart from that, we also have mentor support. Our forums are pretty active. As soon as you post a question, within about 10-15 minutes you get your solution. We also have mentor support from people who've already participated in HackWithInfy, cleared it, and you can just talk to them on how what are the level of questions and everything. So I'm also there on the mentor support, so you can just reach out to me as well. These are some of the topics that we cover in this course. That's the reason is we analyzed most of the previous year's HackWithInfy questions, and we realized most of the questions seem to be coming from these topics. It's not necessary, but like for example, tomorrow you get a question that's related to graph data structures, let's say, or graph. Actually, we do suggest that you study it, but if it is something that's not here, let's say greedy algorithms, we didn't really see many greedy algorithms in this case. Or if you get a linked list questions, we didn't see many linked list questions. So it could just happen, but from the majority point of view, this is what are the kind of questions that have been coming so far. So yeah, if you are somebody who's still preparing for HackWithInfy round 2, wants to just practice as many questions as possible, do sign up for this course and start practicing. So today we'll be going through this question called weird elevators, and let me open up the question for you so that we can all look at the question and understand the question. So just give me a minute. I am opening up the question on the Edyst platform, right? So this is the question called weird elevators, and so here we have said that there is several floors, right? So there's a building with a lot of floors. Each floor has an elevator. You are given two integers x and y. The elevators in the building have a system with the following rules, right? So from any floor number A, you can only move to the floor numbers A by P, which means that if let's say I'm at floor number 20, I can only move to another floor number, let's say 4 or 5, if I can divide 20 by a prime number. So for example, I can't move from 20 to 13 or 20 to 15 because I will never be able to divide 20 by a number such that it will give me 15, right? So I can only move to divisors of 20. So that's one thing I can do, where P is a prime factor of A. So P has to be a prime factor of A to be able to move to a number. And it has to be lesser than m. We'll come to this thing in a bit. The elevator takes exactly 1 second from move to one floor to another floor. I wish our elevators like this, but we don't have elevators like that. Only one elevator can move at a time, right? So you have to find the minimum number of time it will take such that both of these can move to a common floor, right? So the question is a little bit vague. It's not very clear. I'll just summarize the question a little bit. You can go ahead and read the question. This question is available on the Edyst platform in the maths module. So if you just go to the maths module, I'll show it to you at the end. You can see this question, but let's first understand this question fully, right? So what we have is we have one person who starts from X, another person starts from Y, right? So we have one person starting from X, another from Y, and they have to reach a common floor in the minimum number of moves. You can only move X downwards and Y downwards because you can only divide. I can never multiply the X, right? So I can only divide X and move it downward. And so the thing is that X move can only be in prime steps. Not even in prime steps, it is you have to divide it by prime. So you have to divide by a prime number, and that prime number also has to be a factor of X, right? So if you're moving X, you can only move X by prime factors of X. And they have to reach a common floor in the minimum number of moves. This is really important. Otherwise, we can just make them move to 1, right? Eventually, they can all come back to 1. Even prime numbers can divide themselves and come to 1. So eventually, you can all move to 1, but that will take too many number of moves. Maybe 1 is the right answer, but we have to choose the answer in which we have to get the minimum moves. So let's look at the example input. So this is the example input given. Let's take this example over here, right? So we have one person starting at 20, X is 20, and Y is 16. So you have X as 20, Y as 16, right? And we are saying that both of them should move to a common floor. Can they both move to 16? That would be easy, right? Because 16 will not do anything, and then 20 can just move to 16. Except they can't, because X can only move to prime factors of X, right? So for example, X could probably move to, let's say it can move to 10. From there it could move to 2, it could move to 5. When I say it can't move to X prime factors of X, I'm sorry, it can only be divided by prime factors of X. So X can be divided by 2. What are the other prime factors of 20? And 5. That's it, right? And Y can be divided by only 2, because 16 has no other prime factor. So if you keep dividing X, right, what you're going to get is if you divide X by 2 or 5, X can move to 10, X can then also move to 5, and X can also move to 1. Or you could have divided it in another way, right, that X could have moved to 2, right? Can X move somewhere else? X can actually also move to, can X move to 4, for example? Can X move to 4? Yes, it can. If you divide 20 by 5 suddenly, right? So here we divided 20 by 2 first. Had you divided 20 by 5 first, you could have moved to 4, right? So I can move from 20 to 5 by dividing it by 2 and then 2. So the floors I can move to are 1, 2, 4, 5, and 10, right? Is there any other thing? Let me just go through it again. I could divide 20 by 10, right? I will move to 2 directly, and then 2 I can divide by 2 and move to 1, okay? I could divide 20 by 5, that would move me directly, so I could divide 20 by 5, that would move me directly to 4, which can only go to 2, which can only go to 1. I could divide 20 by 2, which I did here by 10, and then I could divide this 10 again by 2, which will move me to 5, right? And from 5 I can only go to 1, right? Because 5 I can only divide by prime factors of 1 or prime factors of 5, and there is only one prime factor of 5, that is 5 itself. For 16 it's a little bit easier. I can keep dividing by 2, so I can move to 2, I can move to 4, so I can move to 8, to 4, to 2, and then to 1, right? So just putting it sorted out, I can move to 1, 2, 4, 8, right? I can do this. And in this, which is the common highest number, or rather the one that would require minimum numbers of moves, it will be 4, right? So minimum moves required is to reach to 4, correct? So I can, in minimum number of moves, I can is required as 4. One second, minimum moves required is different. Minimum floor, one second, floor reached is 4, and the moves required to reach this particular floor to reach this particular floor is how many? 3 moves, right? How did we get 3 moves over here? Well, for 20 I moved to 10 and then I moved to 4, correct? Can I move from 20 to 4 directly? No. 20 to reach 4, I can just divide by 5. If I divide 20 by 5, I can reach 4 directly, right? So then I've reached 4 in one move, right? So for 20 there was one move, plus this is the moves, right? So for 20 there was one move, plus for y, how many moves? I have to divide by 8, and then I have to divide by 2, and then I have to divide by 2 again. So it can reach in 2 moves. So that is 8 to 4, right? So total moves required is 3, and then I can reach 4. Can I reach other floors? Yes, you can. You could reach the second floor as well, but the problem is to reach the second floor you will require more moves, and we have said that we want the minimum moves required, right? So the answer that you're supposed to give over here, the answer you're supposed to give is number of moves required, which is 3, and the floor which I'm reaching, which is 4, right? Let's look at here also. If you look here, we get that the number of moves required is 3, all right, and the floor that we have reached is 4, right? So that's what we are checking over here. Let's look at another example so that we'll get a better hang of it, right? So I'm taking another example here, which is one second, okay, 100, 120 and 10, right? And we are not neglecting this 10 here. I'll come to the 10 in a bit, but 100 I can move to many places, and 120 I can also, move to a bunch of places. But at any time I can, what are the moves that I can make? So for 100 I can divide by 2 and I can divide by 5, right? Can be divided by 2 and by 5. There are no other prime factors of 100, right? It's only 2 and 5. For here can be divided by 2, 3 and 5. There are no other prime factors, but it can only be divided by 2, 3 and 5, right? Finally we'll get a stage where the floor to be reached, right, is what floor can you reach here? So from 100 I could reach 10, but 12, 120 I can never reach 10. I can actually reach 10 over here. So which floor to reach, and moves required to reach floor? Moves required to reach floor, which are the ones? Well, the simplest thing you could do is what is like the if you want to reach in minimum number of moves, if you want to reach a floor, which floor should you choose? You should choose that floor which is the highest common factor of 100 and 120, because that will require the minimum number of divisions to reach there, right? Think about that. If you get the highest common factor, both of them can reach there. Any other floor you reach has to be lesser than the highest common factor, right? And so you will keep going down, you will do an extra division. The one which will take minimum number of moves to reach will be the highest common factor. So if I have to find, I have to find the HCF or even the GCD, same thing, greatest common divisor, highest common factor, 100 and 120. In this case, what will be the GCD of 100 and 120? The GCD would be 10 divides both of them, 20 also divides both of them. Is there a higher? 30 doesn't divide both. So the GCD is 20, right? For 100 to reach 20, I just require one move, right? So 100 divided by 5 will give me 20, right? And 120 divided by 6 will give me 20, except that I can't divide by 6 because I always have to divide by the prime factor. So I can first do 120 divided by 2, then I can do 60 divided by 3, or the other way, I can do 120 divided by 3 and 40 divided by 2. Both of them will reach me 20. So this required one move, this required 3 moves, right? So we are supposed to print which floor I will reach 20 and the number of moves, which is 3. Right? Is that the order we're supposed to print it? No, sorry, we're supposed to print the number of moves, 3, and then the minimum floor, right? So the floor that we're going to reach. So that's why the answer here is 320. If you check here, the answer here is 320 over here, right? That's why the answer is 320. Let's look at the final example so that it will become 100% clear for us. Let's look at one more example, and that example is 160, 180 and 10. 160, 180 and 10, right? So let's look at that. 160, 180 and 10. Again, what is the highest common factor over here? So GCD of 160 and 180 is what? what would be the GCD of 160 and 180? 40 does not divide both of them, 30 doesn't divide both of them. Is it still 20? 20 into 8 and 20 into 9. Yep, that would still be the case, right? Because one of them is 20 into 8, the other is 20 into 9, and there's no factor from 8 or 9 that you can move into 20. So the highest common factor is 20. So we automatically know that the floor we are reaching, if at all we can reach, is 20, right? And M, sorry, not M. So the way we are going to reach is we are going to divide 160 by 8, right? So 160 has to be divided by 8, which means that there were 3 moves of 2, right? So there was which is 2 raised to 3. There were 3 moves of 2, right? So 3 moves here, and 180 has to be divided by 9, right? 180 has to be divided by 9, which means how many moves were there? There were 2 moves of 3, right? So there were 2 moves over here, right? So there are 2 moves over here. So we have total moves as 5 moves, right? So we have total moves as 5 moves, and the floor that we are reaching, is 20. So is that the answer that we have got? Yes, that's the answer over here, 520, right? 520, that's the answer that we have got. Okay, so alright, now that we've got the logic over here, at least understood some of the logic, let's try to figure out what the answer is. But one thing that we have to make sure is we always disregard this constraint that the number you're dividing by cannot be greater than m. Cannot be, always has to be smaller than m, right? So it can't be greater than or equal to m over here. Here we divided it by the numbers 2, 3, 3, 2, right? 2 and 3. These are the numbers we divided by. Let's say an example where this would not be the case, right? So one example where this is probably not the case is something like you could take 14 and you could take 7, right? So if you take 14 and 7, or let's look at a better number, 14 and 35, right? And yeah, 14 and 35, and you cannot exceed 5. That is, you cannot divide by a number greater than 5. So the greatest common factor of 14 and 35 is 7, right? So the floor that they're going to reach is 7, right? Let's keep this as 4 right now. So you can't divide by a number greater than 4, right? Even equal to 4, it has to be less than equal. It has to be less than 4. Now I can divide 14 by 2 to reach 7, right? But 35 I will need to divide by 5, right? To reach 7. There's no other way that I can reach it, so I need to divide by 5. So 35 divided by 5 will give me 7, right? So there's no other way I can reach 7 otherwise. So therefore this is not possible to do. This will simply not be possible to do because why will it not be possible to do? Because we have we are dividing by a number which is greater than 4. We are dividing by a number which is 5, right? We are dividing by a number which is 5, which is greater than 4, so it's not possible. So in such a case, we are just supposed to print not possible. So we're supposed to print -1, right? So just supposed to print -1, that's it, right? Okay. So now that we've understood the question fully, let's try to see what our approach will be, right? So let's look at the approach, right? So our approach is number one, first find the GCD, right? And for GCD you can just use Euclid's algorithm, right? So you can just use Euclid's method of finding it. It's a pretty standard approach. You can just Google it online, so you can just do it like Euclid, right? You do that. If you're using Python, you can actually just use math.gcd, which internally anyways uses that. So you can just do math.gcd and find. GCD you don't have to worry about because GCD is a constant time operation. It depends on the number of bits in the number. So GCD, don't try to optimize for GCD's order. GCD is pretty much optimal anyway, so you don't have to worry about that at all, right? So this is first find the GCD, right? Once you found the GCD, this is the floor, right? So this above is the floor. So for any xy, so any xy that we get, the first thing this is the floor, the common floor at which they are going to reach, right? So that's the common floor. Now that we've got this, find distance of x to GCD, right, and y to GCD, right? So we can actually store it as target. So we store it as a target, and then so we have to find a distance of x to the target, and we have to find the distance of y to the target, right? So this is what we are going to do. Yeah, sorry for that one, right? We're going to find but how do we end up finding the distance of x to the target and y to the target, right? Final answer is distance, distance x plus distance y, right? That's what the final answer will be. And the floor we've already found up before. But how do you find the distance of x to the target and distance of y to the target, right? For that, let's try to look at this, right? So distance, right? How do we get the distance of two numbers? Well, let's look at how much time it will take. So for example, for 160 to reach to 20 by dividing only by prime numbers, right? Or let me look at another way. Let's look at this thing of 120 to reach to 20, right? What is the distance that it will take to reach 120 to 20, right? This your distance you will get because you have to divide only by prime numbers. Otherwise, I would have just done 120 by 20 and I've got 6, right? And I just divide by 6 and I'm happy with that. But because we have to divide only by prime numbers, we need the prime factorization. The prime factorization of 120 is what? It's 3 into 40. So again, I'll just mentally do it. It's 2 into 60, which is nothing but, actually it's like 8 into 3 into 5, right? That's what it is, right? It's 15 into okay, I'm so sorry, I'm getting confused here. So but it's basically like 2 into 60, which is 4 into 30, which is 8 into 15, right? Yeah, so I was correct there. It's 8 into 15, which is basically 2 cube into 3 raised to 1 into 5 raised to 1, right? So the prime factors are 2 cube into 3 into 5. So 8 into 3 is 24, 24 into 5 is 120, right? For 20, what is that? That's what is it for 20? For 20, I have 4 into 5, which is nothing but 2 square into 5, right? So what I am sure about is that in my final answer, I have already one factor of 5 here. I don't need to divide by any factors of 5. I don't need to divide by 5. Only thing I need to do is divide this, right, 2 cube by I have to divide this 2 cube here to get 2 square, which means I have to divide by 2, right? So to reach here, what I will need to do is divide by 2, right? That's one of the first steps, divide by 2, and then I should divide by 3, right? That's what I should be doing, right? So divide by 2 and then divide by 3, right? Another simple way of actually getting that is finding out the prime factorization of the difference, right? So that's the other thing you could do. So for example, I know that it's 120 and this is 20, right? So let me just tell you how we'll go about doing that. So for example, it's 120 and 20, which means I need to divide by 6, right? If I need to divide it by 6, right, what is the prime factorization of 6? It is 2, 3, right? So that's all I'm supposed to do. I'm just supposed to find out, I need to divide this by 6 completely. So what's the prime factorization of 6? Find all the prime factors of 6. That is how many times I need to divide this over here. So that's something simple that you can do at this point, right? Or you could actually get the prime factorizations of 20 and find out the difference between both of them. Anything is fine, right? Both of these work well over here, right? Similarly, to find out, so there was 120 and then there was 100, right? So if I look at 100, the distance of 100, right? So for this is for 120. For 120, I have to divide by 2 and then I have to divide by 3, right? I have to divide by 2 and then I have to divide by 3. For 100, right? What do I need to do? I have 2 square, that's 4 into 5 square, right? Into 5 square. So that's 2 square into 5 square. So 2 and 2 here, the number of factors of 2 are both matched. What I need to do is 5 square needs to become 5, so it becomes a divide by 5. That's it, right? So that's one easy way you can find. Another easy thing you could have done is done 100 by 20, you got 5. Prime factorization of 5 will give you 5 only. So both methods are possible. You don't need to completely prime factorize this. In fact, it would actually be better if you divide both of them and find the prime factorization of the divisor, like how much, what's the amount that you will need to divide it by to get that, right? So that would actually be better for you to do that. And yeah, and I've also done it in the similar way, right? But now the issue comes, have we checked all of the constraints, right? So let's go and check the constraints over here, right? So let's check the constraints. So I'm opening here and then I'm checking the constraints. So I see that in a particular test file, I can get up to 100 test cases, and I can get that x and y is less than equal to 10 raised to 6, which is 1 million, and m can be less than equal to 1 million. Okay, so before I come to the constraints, we forgot to discuss about m. So let me just come back and discuss about m over here, right? So let me discuss about m. Here, if we notice that if you have to divide, and so for example here, 5, like the maximum number that you need to divide by is 5, right? if at all the maximum prime factor that you need to divide by is greater than the m that we need, at that point we say that it's greater than equal to the m that we need. At that point we say that it's just not possible, and we print -1 and we go on to the next test case, right? So that itself can be checked here as well, right? So here we check that, so for example, let me just go back to this. So instead of prime factorizing like this, for 120 to 20, right, so from 120 to 20 I need 6, right? For 100 to 20 I need 5, right? So this is good. Okay, now here largest prime is 3. Okay, here largest prime is 5, right? If m is 4, then this is not possible, right? M has to be 5. Only then can we actually divide this in over here, right? So not even m5, m has to be 6, right? Because it has to be smaller than m. It can't even be equal to m, it has to be smaller than m. So m has to be 6 and above, because here largest prime is 3, so we are fine. But here largest prime is 5, right? So that's the issue over here. Now let's come back to our constraints. So if you check the constraints, we notice that t can be up to 100 and x can be up to 10 raised to 6. If assuming, let's say that y is 1 million, right, or just less than 1 million, the first prime number that's just less than 1 million, and x is 1, which means to prime factorize y, right, or to find the distance, let's look at the worst case scenario here. I'll again come back to my slides, right? Don't want to just hand wave and explain to you. Let me just come back to the slide and show you. So let's look at the worst case scenario, right? So worst case, so you have something like x is 10 raised to 6, right, or just less than that, then it and prime. So let's say x is prime, right? So x is a prime number, let's say, and we say that, you know what, 1 second, yeah, and we say that y is 1 and m is some 10 raised to 6, right? So x is less than 10 raised to 6, so that means that it is always possible to reach at the same one. And in fact we can very confidently say here that the floor you're supposed to reach, is 1, right? Because 1 will be the minimum floor to reach, which means x just has to be divided by itself to reach 1. Okay, but how do we know that x is a prime number? We will have to actually find out if x is a prime number or not. And x is a huge number here, which is somewhere near to 10 raised to 6. Imagine if all of the numbers in the test case are up to 10 raised to 6, which means that for 100 test cases you are calculating all of the values up until 10 raised to 6, which means that you're calculating all the prime numbers up till 10 raised to 6, which means your order ends up becoming, right? So in such a case, right, your order ends up becoming t into n, and let's say you find out x by sieve, right? So we know it's n of log of n, right? So if you find out like using n log of n, right, whatever is the case, you're getting O of t is 100 into 10 raised to 6, right? So sorry, into 10 raised to 6 into whatever is the log factor, that we don't care. It is effectively becoming 10 raised to 8, which is out of the order that we need, right? Because the maximum order we can go to is 10 raised to 6. Instead, if we find out, first find all prime numbers, this will be order 10 raised to 6 log of n, right? So very like log of n is not too big, so it'll roughly be what we need, right? And what you have here is this will be, and for each test case, so this will become plus order 100, because in each test case we're just finding GCD, we're not doing anything else apart from that. So it becomes order n log of n plus order t, when t you don't really care much about because t is just 100, so you just leave tb. So in that case, this is the order you'll get. So from this, the approach we get is in this approach, right? 1 second, where was our approach? Yeah, so in our approach that we are writing, hold on, let me just get, yeah, first find the GCD, find the distance of x to target and y to target, and so on. So even before finding the GCD, first find prime numbers up till max x, right? Where max x is the maximum x that we have received in all of our test cases, right? So the maximum x that we've received in all of our test cases, whatever it is, in this case the maximum the maximum would be 180. We find all the prime numbers up till 180, right? If you have 1 million, we find all the prime numbers up till 1 million, right? So that's what we are going to do at that point. So we find all of the prime numbers till that point, and then we try to get the prime factors. That would become easy because we find all the prime numbers, then we try to get the prime factors of every number, and then we'll get the answer. So let's just go through the approach again, right? So just to bring back to the approach, this is what it is. So find prime numbers up till max x, find the Euclid or the GCD, or you're using math.gcd or Euclid thing, and store it as target. Find distance of x to target, and in fact not even x to target, x divided by target, right? And y divided by target. Like as I was saying, if it's, you don't want to just I'll come to this one. So find distance of x to target and y to target is nothing but, for example, you have to reach to 20, just to x to 120 by 20, find the prime factorization of that, right? So in fact, I'll just word this better. Find prime factors of x divided by GCD and y divided by GCD, okay, and add them, right? And store in distance x, distance underscore x, and distance underscore y, right? So store it as distance x and distance y, and final answer is adding distance x and y. If prime factor greater than equal to m, if any of the prime factors greater than equal to m, print -1, right? Else the final answer is distance x plus distance y. So this is how we'll follow it. We'll find the prime factors of the targets, and after doing that we'll check if any of the prime factor is greater than equal to m. If it is greater than equal to m, we print -1, otherwise we'll just add distance x plus distance y. So I'll show you the code for this one. I've written the code for this, and I'll just briefly guide you through how I went about doing it. So one second, this is how I went about doing it. So over here, right, what we have is, first I've defined the sieve function. So then through sieve, I'm going to find out the prime factors of this particular test case, right? So I'm going to find that one out. So I'll go through the sieve, I'll come through it in a bit. This is, I'm taking input, and again the logic is same for Java, C, C++, Python. I've just done it in Python because most of you are doing Python these days. So your test case, this is the input. I will store all of the x, the y, and the m in an x array, right? A y array and an m array. So I'm just storing all of them. As soon as I get the input, so this is the input that I got. As soon as I get input, I add it to the x array, the y array, and the m array. And at this point also, I'm storing what's the max limit. That is what is the maximum x or y that I have got so far, right? Because it's up till that maximum limit that I'm going to calculate my prime numbers. And after doing that, I calculate all of the prime numbers up until that maximum limit. So I did this over here using the normal sieve function. Normal sieve because there is an optimal sieve. I'll just come to it at the end of the session, but there's an optimal sieve. So I'm just using the normal sieve to find out the max, the prime numbers up till the max limit. I'm storing in the primes list. Now I will again go through the test cases, right? So notice I took the test cases here, I ended the for loop, I founded the prime list here, and then I'll again go through the test cases. For each test case, I'll say that if x or y is 0, then you just print -1, because whatever you do, it's never going to be come to x to 0. You can't divide anything and just get to 0. It's never going to happen. This is not a case that's there, but I just wrote it in any case. Then initially I take the distance to be 0, and this is a flag that considers whether it's possible or not. This is the main part. I just use math.gcd. However, you could also deploy the Euclid function, and it's not too difficult. It's a 3-line function, so just look that up. It's pretty easy to do, right? So the target for x to reach is x divided by HCF. The target of y to reach is y divided by HCF. What I'll do is I'll try to find, this is the prime factorization of x, right? And similarly, the prime factorization of the y's target in any of them. So for example, here, if I'm getting a prime number which is greater than m, right? So if I get a prime number which is greater than m, I'm marking it as impossible. Similarly, if I get a prime number here as a function, as a divisor of y, as a factor of y, which is greater than equal to m, I'm marking it as impossible. In any case, if it's impossible here or if it's impossible here, I'm printing -1 and continuing. Otherwise, I'm just adding both those distances. So I added the distance here, and to that distance variable itself, I'm adding the distance here, and then I'm printing the distance and the HCF for that. Otherwise, I would have already printed -1 and then I continued that point. So really, it's a simple maths question, and this was a 100-mark question. So you can just check all the test cases passing. So it was a 100-mark question, and not really too difficult if you understand maths and if you understand your GCD, your LCMs, and all. You didn't need LCM here, but I'm just saying, you just if you understand all of that, then it's pretty simple to do. Now the one case here that we have missed out and which we have not done is what happens. Okay, so this is the question that I want to leave you with at this point. What happens if the limit for x, so xy we have as 10 raised to 6, right? And we were able to calculate it. But if you do 10 raised to 9, what happens, right? And this is actually one of the test cases. This is a bonus part. If I go 10 raised to 9, you cannot use sieve to find out all the prime numbers up till 10 raised to 9, right? If you try to find out all of the prime numbers up till 10 raised to 9 using a sieve, you will get a memory limit, because more than 10 raised to 6, you cannot assign an array for that. So you have two options, right? You'll get memory error in normal sieve, right? To counter memory error, what you could do is you could do segmented sieve, right? So if you do a segmented sieve, the segmented sieve is order root n in terms of space. The time complexity is still the same. In fact, it's a little slower than normal sieve because you do a duplicate run of it, but segmented sieve will have lesser space complexity. So if you have a space complexity problem, then you can go ahead and do segmented sieve. But in this question, that will still not help, because 10 raised to 9 means our order will go off also. So for that, there are a bunch of other ways, and in the previous video also I was telling you about how to calculate prime factors up until a really large number. So we'll come up with a tutorial for that, don't worry about it. But just to bring to your attention that if it's up to 10 raised to 9, do not use normal sieve. Try to use segmented sieve if time complexity is not too much of an issue and space complexity is the issue. If both time and space complexity are the issue, then even segmented sieve will fail you, and I'll show you a different method on how to solve that in a different video. So right, go ahead, solve this question. Just a reminder to all of you again that if you want to solve this question, you can just sign up for the HackWithInfy Round 2 pack that we have created, only for people who are serious about HackWithInfy Round 2, who already know some basics of HackWithInfy Round 1, who know the basics of programming. If you don't know even the basics of programming, we have a bunch of basic programming courses for you that you can use to start off, right? We have already completed 2 of the Edyst mock tests, but Edyst tests. There are 6 self-scheduled tests which you can take, but there are 4 more Edyst tests remaining. So if you want to come and participate in the mock tests completely on the similar pattern of HackWithInfy Round 2, we even turn on your webcam so you can actually do like a proper video proctored test. So if you want to really practice that, then just join up for this course right away. Reach out to us on the below handle, so either via email or on this phone number via WhatsApp. You can reach out to us and we'll help you out accordingly as well. So, all right, everybody, thank you so much to all the students who are already part of our partnered colleges. You're doing great. You're already on the course. You're doing really great. Keep it up. We see a lot of you online at even 1 a.m., 2 a.m. It means you're really practicing. You're making the most use of this lockdown. We're really proud of you. Keep doing all the courses. Don't forget to complete all the mock tests as well. Final request to everybody, subscribe to this channel and share it with your friends to help us keep producing more content like this. Thank you so much, everybody, and I'll see you all next time. Thank you.